Oh yeah, that's. And also there is net not. Yeah, also net. Yes, next time I need to put it in the non-overlap. All right, it's 9 o'clock, so we'll slowly get started here. Welcome to the second session of this week for the joint session of BMWG and IPPM. Possibly the last time we operate under these names. We'll see. Um, we will confirm, but it's likely that a future name will be BPM. But let's see on the list. Yeah, Nick, do we have the click thing? Note well, it's Thursday. Most of you have seen this a number of times, but yeah, please be familiar around how we operate at IETF, around IPRs, etc., anti-harassment policies and such. If this is new to you, please scan this QR code and read a bunch of documents. Know really, really well that we conduct this in a professional manner, and if you feel that you're not being fairly treated or feeling that you're harassed in any way, there are a number of procedures. There is an ombuds team that can help you in these situations. You have the resources here as well. Meeting tips, you should be aware of these. Please make sure that everyone in the room signs into the session. It's very important for us for planning. Join the mic queue before you go up to the mic. If we have show of hands tools, you use the tool specifically for that. If you're not using the light client, please keep your audio and video off. If you're remote, also keep your audio and video off unless you're chairing or presenting. And as usual, it's a good idea to use a headset if you are remote when talking. We do have a note taker. Thank you very much, Stuart. We have a very packed agenda today, a lot of interesting topics, and we also urge everyone to try to stay on time as good as possible. We will start with a suite of documents by Giuseppe, where a number of these are in working group last call, but there are relations to more documents. So Giuseppe will do an overview, and then Nalini will talk about an update to encrypted PDM. We will have a Power Bench presentation, CV benchmarking. We will have IOM for MPLS, so that is adjacent work to the IPPM, you would say. And then Greg will talk about class of service ECN for stamp. We also have a number of presentations on proposed work, as you can see here, ranging a large amount of topics. I will not go through them all here now. And if possible, if we make it to this slot, we have a number of lightning talks. And the idea with these lightning talks, these are all if time permits. And if we make it here, we would urge anyone who presents to do one slide, brief overview of what it is you're working on so that we can go through all of these. Thank you. Is there anybody who wants to bash this agenda? Take that as a no. Then we move forward with the first presentation from Giuseppe.
Yeah, okay, good morning. This is an update about this family, with set of documents about the alternate marking. So this is the first one about the deployment framework that has already concluded the working group plus call recently, but we just want to provide an update to give the full picture and to see how the different documents are interconnected. So the first document about the deployment explain how to deploy the full solution, and especially it's clarify different aspects related to the applicability scenarios, like the controlled domain, the rule of the nodes, the type of measurements. But in addition to that, the main point is that the Wolf framework also defined the different options for the configuration, so the possibility to use YANG, PSEP, PGP, and for data export, so YANG push and IPFix. And reference the relevant documents that are also in other working groups. So, for example, the YANG model is in IPPM, but for IPFix is in OPSA-WG. So we are discussing with the OPSA-WG chair where to do a joint working group plus call for this document, for example. After the working group plus call, we received some feedback. The new version addressed several comments from Benoit, Alex, Tier, Tim, and all the comments have been addressed. So we especially clarify in the introduction that this document is the base document. There are other complementary documents. We also explain that there are two options for the computation. The first option that there is a collector, the other option that considering the recent publication of the RFC 9951, that each node can do directly the computation on the node, assuming that the counters and timestamps are carried with the packet. You can see RFC 9951 for reference. We also extended the definition of controlled domain to consider the case of trust relationship between different entities. Of course, we added the operational consideration section as well. For the YANG data model, we also update the YANG model, and the main change, thanks again to Benoit and Alex for their reviews, we clarified that this YANG model is only for configuration. There is another YANG model that is for telemetry, and it collects telemetry for not only for alternate marking, but also for IOM and on-path delay. We redefined the module to include the profiles under the interfaces because it's more coherent. And we also revised all the cross-references between the corresponding parameters in YANG and IPFix, just to help the implementers to understand the correlation between the parameters across the different tools. For the YANG push, similarly the same. We also, in this case, we addressed the comment from the ASI, Benoit, and Alex, and we redefined the module similarly to the configuration model, and also we had cross-references and the operational consideration as well. We are still waiting for the performance metrics review from Paul that will be also made jointly with the configuration model in order to check the consistency between the two. The last one is in OPSA-WG, is the IPFix extension. Just a recap, basically we use the same information elements that are already existing, but we need to add new information elements to accommodate alternate marking needs. So in particular, the flow mon ID, loss flag, delay flag, and the period number. Benoit also detailed reviewed this document, and the relevant changes are explained here. So we improved the description of flow aggregation, correlation, and measurements. We changed the name to align with the naming convention of IPFix. Also in this case, we clarified the two options for computations, because after the publication on the RFC 9951 and 9947, there was another option for computation that is now enabled. And of course, we check the cross-references. That's all. Next steps. So the deployment draft and the YANG model just concluded working group plus call. So maybe for the deployment, it can be moved forward. For the two YANG model, we still need a review to check, as I said, the consistency. the Young will be updated soon in preparation of the working group last call. And also for the IP fix, there is a plan to do a joint working group last call with OPSAP WG. Of course, comments are welcome. Comments?
All right, then thanks a lot, Giuseppe. Now PDM v2. Do we have Nalini here? Yes.
Okay. So some of the comments that we had on PDMV2 had to do with how the registration, policy, ciphers, and all this kind of carrying on was going to happen. And so we've taken a bunch of that stuff out of scope. And so all the security context and everything will be done beforehand. And what we did is we actually did this using a radius EAP registration flow, and that is all in there. Certainly, you can use something else. It's just an illustration of how a registration can be done with a, a relatively well understood registration model, such as radius. Okay. And so, as I say, a number of the problems had to do with cryptographic mechanisms, how all that was to be established. And so we have taken that out of scope. Yeah. Um, so we concentrate just on what PDMV2 will do. So kind of the way things go is that you will register your devices. You will decide who's going to talk to whom, policy, etc. And then the measurement. And that is what we are concerned with in the PDMV2 draft, is exactly what will be measured, what will be the data structure and packet contents. And then analysis is also out of scope. Whoever is going to analyze said packets, whether it is in real time or after the fact, will be a registered participant, however that policy is done for your network. Okay. Um, and there were a number of key use and layering concerns. So since PDMV2 operates at the IPv6 layer, we can't simply use TLS or DTLS or anything like that, because it applies across the other upper layer protocols, and none of these lower level protocols or upper level protocols are non-unique, and so we don't reuse any of those keys. The registration exchange is an entirely separate set of events, and that can use whatever mechanism you would like to use. PDMV2 is separate from PDM. PDM RFC 8350 was the unencrypted PDM. And again, the reason we wanted to have it encrypted is we feel that the data divulges too much about the nature of the endpoint and can potentially be used for attacks. And so we will ask for a new allocation from IANA for this, for PDMV2. That needs to be updated in the draft. Yeah. And so those are the two things that need to be updated in the draft, asking IANA for a new option type and the wire format. Okay. And so now we are ready for another review. And if we can get an early review from I believe SEC area, and I have to look and see what other area already had comments. But for the chairs, we are ready for that. And if anyone has any comments, please let me know. There are, I believe there are implementations of PDM in India already. They used it for measuring DNS performance. We ourselves have an implementation as well, and I imagine they will do PDMv2 also. Comments, thoughts? I think that's it.
All right, thank you very much. Any comments from the room? Yeah, I see Med in the...
Yeah. So first of all, thank you, Nalini, for reviving this work, and then we say trying to push it forward. I think that's encouraging to see that the update and also the approach you have, I would say, adopted so far to offload, I would say, the contentious part of it. So let's hope that this will make it this time. So yeah, before I would say starting again the process here in the working to have the working protocol and so on, make sure that we have all the pieces we need from the SecDir. At least we request security directorate, internet directorate, and ops. At least for those. Once we are, I would say, confident that the new design, I would say, and the sketch is really sound, then I will be more than happy to take it back to the AG for review and so on this. Thank you, Nelly, again for.
Yeah, thank you so much.
Yeah, thank you, Matt. That's exactly what we were going to suggest here, to do a number of early review requests first, and then take it from there. Perfect. Thank you very much.
Yeah, thank you, guys.
Next up is Shailesh.
Yeah. Good morning, everyone. My name is Shailesh. I'm from Nokia, and I'm going to present the latest updates to the draft on the characterization and benchmarking methodology of PAR in networking devices on behalf of all the authors. So for folks who are new to this draft, just wanted to give a quick context and recap. So the goal of this work is to kind of come up with a standardized benchmarking methodology to evaluate energy efficiency of networking devices, right? So the idea is to provide a consistent way to characterize power consumption of network equipment under repeatable and well-defined test conditions, right? So the focus is on the device level power consumption under controlled traffic conditions, which enables us to it enables two key use cases, which is comparison of energy efficiency across devices and also assessment of the system power consumption and also the contribution of the subsystem components to the overall power consumption, right? So this is an adopted draft, and it has been presented since IETF 119 Brisbane and has evolved based on the working group feedback and comments. So we have, ever since IETF 125 Shenzhen presentation, we have, revised the version, and one of the updates is that, we have an update on the benchmarking environment and measurement conditions. So we realized that, the power measurement can get influenced by laboratory environmental conditions, especially temperature. Which was not explicitly defined, right, in the draft. So now the draft recommends laboratory environmental conditions based on that CES 203136. Specifically, the temperature between 23 to 27 degrees Celsius, relative humidity between 25 to 75%, and atmospheric pressure between 812 to 1060 hectopascals, right? So this kind of improves the measurement reproducibility and especially the cross lab comparability. So the second update we had is over some clarifications over the existing benchmarking scenarios. So for base power procedure, we clarified that all the boards and components must be fully booted before the power measurement is taken. We also added a rationale behind the 1 packet per second traffic used in the ideal plus power. So the intent is to send base minimum traffic that is required to bring the networking device out of the low power or the sleep state, right? So that improves consistency and once again reproducibility of benchmarking procedure. So we added a new benchmarking test called typical power, which is basically drawn by the data under representative operation conditions, and that complements the existing benchmark test as well, right? So we had a couple of more updates to the draft where we strengthened the iMix traffic as the traffic repeatability specification. And we also clarified that the non-drop rate or the zero packet loss is the default benchmark assumption, and any non-zero packet loss must be explicitly declared during the benchmarking procedure. And we also removed the inter-packet delay as a mandatory traffic parameter because iMix is already a well-defined traffic profile. So we thought it was unnecessary, and it simplified the benchmarking methodology for us. Yeah, so on the latest updates, we wanted to request the feedback from the working group, and also we want to investigate the alignment opportunities with the ongoing green working group, right, work. And also I wanted to request the working group and also the chairs that if there is consensus, we want to assess the readiness for the working group last call. Thank you.
Comments on this draft? Yeah, as we mentioned, as we also highlight in the slide, maybe before moving towards the working group plus call, we need more inputs from expert on energy efficiency.
Sure.
Yeah, because it's an expertise that we lack in BNWG, IPPM, and yeah.
Right, sure.
This is maybe some reviews.
Yeah,
can be useful. Yeah.
Correct. Maybe in the audience, I might request some experts from Green Working Group to kind of review the draft. Maybe special request to you to provide some comments in view of the Green Working Group work, right? So that would be really helpful for the draft. Thank you.
Thank you. And next up is Libin.
Good morning, everyone. I'm DB Liu from Zhongguancun Lab. I will present updates on the benchmarking methodology for intra-domain and the inter-domain source address validation on behalf of my co-authors, Li Chen, Dan Li, and Lan Zheng. So let's first overview the document and have a look at the document status. So this document provides benchmarking methodology for intra-domain and inter-domain SAO, which evaluates the SAO accuracy in terms false positive and false negative rates, control plane and data plane performance, and the resource utilization. It adopts a black box and mechanism and implementation agnostic approach. This document was adopted by BMWG in February this year. After that, we updated the version 0 and presented it in the IETF 125 workgroup meeting. Based on the relevant discussions in the subnet workgroup, we had updated 2 versions. For this meeting, we will present the version 03. This is a summary of the main updates. In the document, we had clarified the scope of intra-domain and the inter-domain SAO based on the discussions about the distinction between intra-domain and inter-domain cell in cell network group. And we also updated the terminologies to align with the relevant documents in cell network group. And we refined the test methodology and the definitions of the key performance indicators, and refined the test cases for intra-domain and inter-domain cell, as well as expanding the reporting format section. This is a conclusion of the discussion on the distinction of intra-domain and the inter-domain cell according to the discussions of the work group last call for the problem statement drafts in cell network group. So for the intra-domain cell, the deployment points is the external interfaces connecting to customer network with no S and a single host or a set of hosts. For inter-domain cell, the relevant deployment points is the interfaces connecting to neighboring AS, which may use a public AS number or a private AS number. So for this document, we use the same concepts to define the benchmarking test cases. We have added some new terms and refined some other definitions of some existing ones. We had added limited propagation or prefix, abbreviated as LPP, which represents the prefix configured with no export, no advise, or other selective export policies. Hidden prefix represents a prefix that is not visible to the routing information, which usually caused by the direct server return DSR. DSR uses any cast service addresses while delivering data from edge servers that do not announce these addresses in BGP. We have refined the definitions of cell-related and cell-specific information. Cell-related information means the information that is originally proposed for non-cell purpose, but may be used for cell. Cell-specific information represents is specifically proposed for source address validation. For intra-domain cell test cases, we had removed the test cases for internet-facing and the aggregation router-facing network, as well removing the test cases under policy-based routing and faster router scenarios. This align with the definitions of intra-domain cell, which works at interfaces connecting to a neighbor AS, a neighbor network with no AS or hosts. For inter-domain cell test cases, we refined the test case for cell on customer interfaces under the scenario of hidden prefix caused by direct server return. We have refined the reporting format section. There are more test configuration parameters included to improve the clarity. They include the DOT deployment type, intra-domain interface type, inter-domain relationship type, routing configuration, subtable size, and update characteristics, number of repeated runs, and the statistical treatment of the results, some mechanism and configuration, and the test traffic attributes. Okay, many thanks to all the people for their valuable comments and reviews on this document. For the next step, we are going to improve the clarity and the completeness of the test procedures in the document, and we will continue discussions in the relevant work groups and revise the document based on the community feedback. So thank you for listening. I'm happy to take your questions. Any comments?
Lan Cheng from Zhongguancun Lab. Just a second, Li Bin. The current version of this document is aligned with two important documents in sub-networking group. The first one is the intra-domain sub-problem statement, which is already in the RFC queue. And the second one is the inter-domain sub-problem statement document. It just passed the working group last call and will be submitted to IESG evaluation. So I think the test cases in this version should be stable because the problem is identified. So, but we still welcome feedback. So I think this is a very good chance because the another document is still in evaluation. So I think there is a good chance for others to look at the new version and the feedback are welcome.
Thank you.
Thanks.
All right, next up is Rakesh.
Good morning, everyone. My name is Rakesh Gandhi from Cisco Systems. Presenting this MPLS working group document on MPLS IOM on behalf of my co-authors. So we requested the working group last call in MPLS, and chairs asked us to present this here because IOM work was done in this working group. So agenda is look at the requirements and scope, the IOAM encapsulation in MPLS and the next steps. So requirements basically to support the IOAM, both the IOM as well as the DAX option types in MPLS. There are RFCs 9197 and 9326 that define those option types, and using the M&A in-stack and post-stack network actions. So the IOM is realized as post-stack M&A, and the DAX is realized as either in-stack or post-stack M&A. And the incremental trace option is not supported. There is a typo in the slide. So the first one, IOM and DAX in post-stack, there is an in-stack M&A that contains the opcode that there is a post-stack data for IOM, as well as where the data is, the offset, as well as the scope of processing, edge to edge or hop by hop or select, and what to do if it's unknown on the node. And the actual option type that's defined in 9197 or 9326 is carried in the post stack. And it's just an encapsulation there with a post stack base header, but the option type is carried as is. And DAX is also supported in ISD. Basically, the same option type is carried in stack, but a bit of a formatting change because of the S-bit and the BSPL aliasing. But there is a flow ID as well as sequence number carried the same way it would be for other data planes. So the M&A has scope for I2E, which is end-to-end or hop-by-hop or select, and based on the scope, appropriate option type is carried in the MPLS packet. So requesting a couple of network action opcodes for the first solution as well as for the DAX in ISD. So we welcome your review comments and suggestions. IOM work was done here. So I'm sure there are a lot of good ideas in this working group. And we have requested MPLS working group last call in the MPLS working group. Thank you.
Thanks a lot, Rakesh. I think this is very important work. It brings IOM into MPLS, and I understood you're aiming for working group last call. So I think for the IPPM and BMWG community, this would be the right time now to review the document and to give feedback. Thanks.
Thank you.
All right, next up is Greg.
Good morning, Greg White from Cable Labs. So a brief update on the STAMP class of service extension for ECN. This is a draft that was adopted by the working group last fall, I believe. And the purpose of the draft is to define define a STAMP extension that allows STAMP to be used to test traversal of ECN in both the forward direction and the reverse direction. There was originally a class of service extension in STAMP that unfortunately only allowed the forward path to be tested with ECN. So this draft revises the class of service extension to handle the reverse path. So the current status, I posted a draft 01 on Monday, only 2 changes. The first one is a technical change. There was an ambiguity about what a session reflector should do if it for some reason is unable to set the ECN value that was requested by the session sender. So to make that deterministic, we're mandating that the 00 value or not ECT be used in the reflected packet. And the second change is to add a reference to a TSV working group draft that is nearing publication. I think it's in the editor queue that talks about how to use or how to set the ECN value in different operating systems. In addition, there's been some discussion on the mailing list. Actually, it was during the adoption discussion for this draft, an alternative encoding of this class of service information was suggested. We haven't reached consensus on any change there. Through the discussion, it's essentially the main difference between what we have in the draft and this alternative proposal is the alternative explicitly includes the diffserv code point and ECN values that are being used in the test in both the forward path and the reverse. And that would enable an on-path observer to understand the test and be able to detect manipulations of the diffserv code point or ECN value at different stages along the path, which is an interesting feature for sure. The main problem with it is it throws away the backward compatibility. So with the current draft, we have backward compatibility. A session sender can talk to a session reflector, even if one of them supported the old version of the class of service TLV and the other one supports the new version. So I expect a continued discussion on that on the mailing list. Hopefully we can reach consensus on that and move on from there. There's also some off-list discussion between the authors, and Will Hawkins had raised an issue where, and this actually was an issue with the original class of service TLV as well, that the behavior was undefined if the session reflector can't use the requested diffserv code point or the received diffserv code point for its reflected packet. And we have a little bit of analysis of that on the next slide. Also hoping to do an interop at the next hackathon. So if anyone has a STAMP implementation and would like to work with us on interop testing, please join us at the next hackathon. So this is that one issue that I mentioned. So currently in a received STAMP packet at the session reflector, there's the diffserv code point on the IP header, and the session reflector inserts that as a value referred to as DSCP2 in the reflected cost TLV. That the received class of service TLV also contains a DSCP1, which is the session sender's requested value that the reflector should use in its IP header. And if it's not able to do that due to limitations in the system, the session reflector system, or configuration that prevents use of that district code point, the draft currently, and actually the original class of service RFC, says to use the received IP district code point. And it sort of leaves it ambiguous as to what to do if the session reflector can't use that DSCP2 value. Listed out 4 options, probably need to take this to the mailing list to kind of do the analysis of which option is best. I think we're sort of leaning towards option 2 or 3 based on just discussion between the authors and Will Hawkins. Yeah, we'll take that to the list. One other point is that that class of service V2 proposal doesn't have any ambiguity here. The session reflector can just list what code point it did use in its response. So a session sender can get that information and know unambiguously what the session reflector had used. So that is the status. I can take questions if there are any.
Any questions from the room or from remote?
Looks like no.
All right, thanks a lot. Oh, there, Giuseppe.
No, I think it's quite interesting. I just want to point out a draft about the combination of active tools and hybrid measurement to also to make hop-by-hop measurement to combine. So maybe this can be mentioned as a possible improvement. So you can also make compact measurement and hop-by-hop measurement by leverage the hybrid tools in combination with STEM. So that's quite interesting. Also for the L4S application.
Right. Yeah. So that is definitely an advantage of that cost V2 proposal. So I agree. I think that would be a nice feature. So
I will point out the draft, so maybe you can extend in a new section to mention this.
Okay. Great. Thank you.
Okay. Next up is Bin Young. So we'll talk about a suite of documents that was originally proposed for CCamp, and now it's a bit of a split.
Good morning. My name is Bin Young from Etrist. I will present the 3 documents on the collections measurement on behalf of the author and the supporters. And the history. This work started a single document, a young data model of PM streaming at CCamp 2 years ago. And just before the working adoption poll conclude, I got a comment. It contained the generic performance management requirement out of scope for the CCamp. Maybe it's the IPPM working groups, maybe responsible for it. And so we had the online meeting and the email discussion with the 2 working group chairs and ADs. And so finally it was agreed that a generic part should move to the IPPM working group, and while the technology specific and the transport networks remain as CCamp. Now we propose the split into 3 documents. And the 2 documents for the IPPM, 1 document for the CCamps. And especially is the I like to thank to the chair and the ADs and to including Chino, give me some opportunity to share my work with you. Especially thanks to Thomas, because he's given me a clear guidance which working group I should go with this draft, including many things. Okay, original document is the mixed two generics young data models of PM collection and the PM interval capability, and then technology specific young model of PM parameter and transport specific. And so the two genetic models was taken out to move to the IPPM working group as a separate documents. And PM's parameter, technology specific young data model remained the CCamp. And the outline of the three documents. First, the document and the collection measurement. And for the IPPM standard track, it includes the genetic core models, including parameter, sampling collection, interval hierarchy, three types of collection measurement. And the second document about the interval capabilities. It augmented the first young data model and make the server advertise the interval capability to a server. The third one is the PM streamings on transport, and for the IPPM, CCAP document, it import to the first and the second young data model to specify this, how to support the PM streamings in transport equipment. It also defined this the common transport parameter modules and the profile. Okay, the first document in detail, it described the three-stage pipeline of performance management processing within the equipment. And the sampling is the first stage. And this model, this draft modeled the second collections stages. And it processed raw performance data, captured at the first stages, and produced structured performance data, and removing the unnecessary performance data. And then performance data is delivered to the client. And this draft also defined the three collection types counts as captured the total number of events accumulated of a collection interval. Snapshot and captured the instantaneous value at uniform times every interval. Third trademark as the captured minimum, maximum value every intervals with the threshold. Okay. This draft is the proposed hierarchical structure, young data model, and starting from the profiles and the parameter and intervals. And the right figure shows some hierarchical relationships between the sampling interval and the collection intervals. And for example, a second network operation center can be monitored by the count measurement. And well, we did a 1 second interval over 3 different collection intervals for the different purposes. For example, 1 minute collections for rapid fault alert, 15 minutes for the maintenance. And they show some relationships. One sampling interval can be mapped into the multiple collection interval as a hierarchical architecture. And this slide, those slides show the relationship between the terminologies used in draft and the terms in the IPPM framework working document. And so the terminologies of collection types should be aligned with the IETF IPPM framework document. And for example, snapshot correspond to singleton, and counts and the title marks correspond to statistics of sum and the min max as a temporal aggregation, and RFC 6319. Also, this draft is try to minimize the collection type, 3 collection types, and based on the GDA 7710, because it picks the small operational valid data set instead of all possible statistics, including average variance of the statistics are not included in draft. And so it keeps any side computational light, heavy analysis in the external system. Okay, second document is about advertising the interval the server supported. It augmented IETF system capability, RFC 9196, and so that it also mirrored the first young data models profile and parameter structure. There are several reasons why the discovery of interval capability is needed, because one of the parameters that can be measured by the multiple collection interval. Sometimes sampling interval can be variable. In this case, server should know the capability, interval capability server can support it. Advanced people configuring the collection measurement. Okay, this draft defines the metrics of the interval capabilities with the min max value and unit and granularities. Okay, so the document is about applying the first 2 modules to transport the equipment by importing the first and the second young modules. It also defines the 3 group of performance parameters. First groups can be monitored by one of the 3 collection types with 15 minutes for the maintenance. It can be the short-term operations, rapid fault detection. Second groups can be monitored by one of the 3 collection types with the 24 hours collections for the maintenance. For example, daily trend, strategic planning, and the third ones can be monitored by the owner's count measurement with the 24 hours for the QS monitoring. That can be the SLA compliance and the QS reporting. And this draft also addressed the whole procedures of end-to-end streamings from the discovery interval capability and streaming the performance data. It started at the first stages and the servers advertise the interval capability to the servers, client, and the client based on the information subscribe the performance data and the interesting. And then after configured, and the servers stream the performance data periodically. After that, some threshold report is triggered, and when the threshold values cross the monitoring value cross the threshold value. Given the nearly 2 years of review in the CCAMPs, we believe that the work is mature. We do welcome a prompt working adoption call. The reason is that I'm a little worried about another 2 years by IPPM reviews. And anyhow, I want you have a deep comment, deep consideration on this document, and all comment is always welcome. So please referring the GitHub links below. Thank you.
Thanks a lot, Ben. And absolutely right. I think there is a lot of work already in those documents. And I think we will make sure on our side that we can quickly move forward to an adoption call. I have one question. I was checking on whether there are existing ITOT liaison statements on this work, but I haven't seen any. Do you know, are there any liaison statements currently open? If not, I will clarify with the CCAM chairs.
Not that. And so I try to, so
Okay.
do that.
Good. Okay, then I think we're going to initiate something just to be sure that the ITOT community is aware of this work.
And so the revisions is planned to start next year. Now currently we are working on the GIDA 7710 document.
Okay, perfect. Thank you.
Okay.
There are other questions. One is from me. So I'm wondering whether during the processing of measurement, did you consider how to categorize the data eventually differently depending on whether they are performed with active, hybrid, passive methods, considering the IPPM terminologies?
Yeah, so this draft does not consider any OAM mechanism, in-band, out-band OAM. Just after getting this the OAM data, raw performance data. From
No, I mean the data, classify the data maybe with a tag if they are performed with different active, because the information can be useful when you collect based on the kind of methods.
The metadata is necessary.
Okay. Probably. Yeah, we can further discuss because to align also with IPPM terms, and maybe it's an information that can be added as metadata. It's something to consider. We can. Because I didn't look. I will look more deeply to the young, because from a quick look I didn't see this categorization. Maybe it's useful.
If you look at my suggestion, there might be the profiling of the set of performance parameter. In that case, it has some characteristic of the performance.
Yeah, something like that.
Okay.
Well, maybe some explanation will be good and some additional information on that. Chin.
Yeah, Chin, actually, thanks for this update. Actually, break it down into 3 drafts that resolve a lot of overlapping issue. And my comments, for the, you have 2 drafter, both actually is a young data model. One of the young data model is a system capability. I'm wondering whether this should be, the developer in the netconf, or this should be combined into the single draft. Just feel the chair need to make a decision on this. Second is there's an error mapper working group. They already get concluded. They define the error mapper name and the young data model, and I see a lot of maybe some building block you can reuse, so you can check whether there's something overlapping, or you need to clarify how this related to error mapper young data model.
Yes. Okay. Let me know the detail. And anyhow, the first document is the collection measurement. Main is focused on the collection measurement based on the GIDA 7710. Second one is really different capability issue, not is based on the GIDA 7710. It's a little bit separate issue. Okay. Thank you.
Sure.
All right, and next up is Lancheng Jin.
No, this one. The benchmarking methodology for relying party. Yeah, APKI relying party.
Yes. It's too small window here. This way. Yes.
Yeah. Yeah. Hello, everyone. I'm Lan Chengqing from Zhongguosun Lab. So this draft describes the benchmarking methodology for RPKI, relying party. So here is a brief introduction to RPKI and the relying party. RPKI, Resource Public Key Infrastructure, is a public key infrastructure that represents the allocation hierarchy of IP address space and AS numbers. And then resource holders can use RPKI to publish signed objects such as ROA, ASPA to provide the authorized information for BGP route filtering. And relying party, the RP, links the RPKI repository to routing system. It's a very important role. It retrieves RP objects from the distributed RPKI repos and validates these objects and generates the validated output, such as the validated ROA payload for use by routing systems. So why do we need relying party benchmarking? There is an answer. Currently, there are various relying party implementations, but they may differ in their internal validation workflow and processing strategies, and they may differ from some RPKI IFC requirements. And we note that some deviations from IFC requirements can be difficult to identify if we don't have a controlled repository or without well-defined test cases. And the benchmarking methodology is also useful for both relying party developer and the relying party user. For relying party developer, for me, like me, I'm a human, not a machine, so I may miss or misunderstand some requirements, standards in the IFC. So I may do something wrong in my implementation, but I didn't know that if I don't have a benchmarking methodology to test it. And for users, for operators, they also want to know how do I select one that meet my requirements among all of those available RP implementations? How can I to choose the one I like? So this draft answers the question, how can we consistently evaluate and compare the correctness and the processing performance of different relying party implementations? So this document includes the benchmarking methodology in a controlled laboratory environment and is a black box test based on only externally observable outputs, such as the VIP sets. And before we write this document, we share our thoughts with several RPKI relying party teams. And the feedback is that the correctness is the most important property. And the performance improvements are meaningful only when the relying party produces the correct validation output. So we consider functional correctness of required validation procedures as the primary evaluation objective. And we also measure the performance. Here shows the black box benchmarking test environment. Here is a controller and servers and the software under test, which is also a relying party. The servers host and publish the controlled RPKI repo, and the software under test retrieves and validates the objects in the servers and provide the validation output to the controller. And for the controller, it controls the repository content and start tests and compare the relying party's output with the expected output. The general test methodology is very straightforward. We first start from a known valid repository generated by the controller, and we run a test. And then we can get the valid VIP set. And after that, we will modify one object or modify a test condition at one time. And for example, we can introduce a malformed ROA or malformed manifest. And then we perform a cold start run again. And then we can compare the generated VIPs with the expected results. And all of our functional correctness test cases are derived from validation requirements defined in the relevant RFC. And we try to evaluate whether an relying party correctly performs the required validation procedures and produces RFC conformant output. And for example, we will test the DER encoding correctness, the syntax validation correctness, and the certification path validation correctness, as well as the signed object signature validation correctness, and also for some processing correctness or manifest, CRL, or other types of RPKI objects. And for each test case, we define the objective, the procedures, and our expected results. Due to time limits, I cannot introduce all of the test cases, but here are two examples. In the first example, we first built a valid baseline repository and run the run party. We can get the valid VIP set, and after that, we can modify one row, make it malformed, such as we introduce a wrong syntax format, use a wrong signature, or do some bad issues to that API object. And then we perform a cold start run again, and then the expected result should be that the VIP derived from that malformed ROAS should be absent, but other VIPs should remain. And we also test the performing time for relying party, but in current version, we only focus on a one-shot validation run, and the controller will calculate the time from when it starts the run to when the SUT provides its VIP set to the controller. And the controller can decide how the VIP set is fully received. So in next step, we plan to expand the test coverage by adding additional test cases such as the CRL processing correctness validation and the processing time test and the daemon mode operations. And we also welcome feedback, and there are two questions for the community to consideration. Yeah, and we thank to Huiho and the Fort RP development team and Misha for their reviews and comments. Thank you.
Thank you. Question, comments? Yeah, if no one, I have a question. I just noted that you also present Insider Ops this week, right?
I requested a presentation, but that didn't.
There was no time.
Yeah, it's not included in the agenda inside the.
Okay. Because I was curious. I was wondering what was the feedback from Cider Ops, because since the experts are there.
Yes, so. But I sent email on the Cider Ops main list.
Okay.
Yeah, and I say Misha is here. Right. So yeah.
Okay.
Thank you.
All right, and then we welcome Rakesh up again. Going to talk about STAMP MPLS header. So this was originally part of a common document that was split, and that one part is through working group last call, and this is the other part.
Yeah. Good morning, everyone. My name is Rakesh Gandhi from Cisco Systems. Presenting the stamp for MPLS extension headers on behalf of my co-authors. So we look at the requirements, updates, summary, and next steps. So as Marcus mentioned, this was part of a working group document, and we split it into IPv6 MPLS about a year ago. And IPv6 just completed working group last call, and MPLS, I think it's in the state where we made the parity with IPv6. So they both should be in the exact same state except different data plane.
Do you want to merge again? I'm joking.
Yeah, it's in the IESG now, so it's a good idea. So requirements basically using STEM for hop by hop and S2S measurements using M&A. So in some way, this is the use case document for the MPLS IOAM solution that I just presented a few minutes ago. This one shows how we can use that MPLS IOAM with STEM to do hop by hop and S2S measurements for both one-way and two-way. The scope is really STAMP and all of the M&A as well as IOAM RFCs. So just to give a summary, there is M&A in stack, there is M&A post stack that carry various IOM information, and the payload is STAMP in this case, and there are STAMP TLVs. We do hop by hop measurements, and on the reflector side, everything that's collected in M&A is copied into the STAMP and send it back to the sender. There's a header control, so if you want to do measurement in the reverse direction, we also add the MPLS headers in the reverse direction in STAMP. So that's the gist of the solution. And IPv6 works the same way for IPv6 extension headers. So we made quite a bit of updates to keep up with IPv6. This was presented in Montreal. Since then, Fabian has joined. Actually, Fabian implemented this also in open source and gave very good feedback and improved the draft. So thank you, Fabian. We presented this draft also in MPLS working group session to get their feedback. The same way we did for IOM presenting here, we did this one in other working group in Shenzhen. So many updates to keep up with IPv6. There is requested bits that's defined in the header, the clarification of conformance, how the MPLS header is processed on the egress node. We clarified that as well. I think Greg had comments on that. There is a M&A header control sub TLV. It's used to add the headers in the reverse direction and conformance for it. We clarified all that as well. And then operational and security considerations also updated to match the IPv6 part. So we asking for 2 code points, one a STAMP TLV and a sub TLV for the type 12 in the reflected packet control. There is an implementation, open source code is available, thanks to Fabian. So we welcome your review comments and suggestions. This draft was part of our working group document. There is an implementation, so I think it's good time. We did request the working group adoption on the mailing list. And thank you.
All right, thank you. Do we have any comments from the room, from remote? Anyone? If not, it's very encouraging to see that there is open source implementation of this. That is very much appreciated and in line with how we want to see things move forward. So this is definitely one of the priority items for us to adopt. So we'll take that into consideration.
Thank you.
And yeah, you can stay on.
Again, I'm Rakesh Gandhi from Cisco Systems, presenting the draft on residual BER using STAMP. We love STAMP. It's simple. On behalf of my co-authors listed here. So agenda is look at the requirements, updates, summary implementations, and next steps. So this is a residual bit error rate measurement. So that's the bit error that escapes the CRC detection and FEC correction and result in UDP checksum errors, for example, and we measure in both directions. And we want to get a very good approximation of the residual bit errors, and this is STAMP. So we welcome Lee as co-author. Looking forward to working with you, Lee. We address comments from Ernesto, Karsten, and Lee as well. We added new TLV. There was an ask for it to detect the burst in bit error, so we added that. We clarified various things, including unknown flag, and the pattern must be integer. The padding must be integer of the pattern size, and many other editorial changes. We are also added Cisco's shipping implementation. We're shipping using experimental code points at this point. So just to give a summary of the procedure, STAMP is used with extra padding TLV, and padding contains the a bit pattern that's also signal or locally configured, and reflector basically matches the pattern in the padding and looks for the bit errors and the burst, and puts the data into the STAMP TLV and sends it back to the sender. So that's the gist of it. There are three TLVs defined for the pattern, the bit error count, and the burst. So Cisco does have implementation. It's shipping. There is a CCO documentation on how to configure it and use it. There is also open source implementation. Thanks to William, it's available. All using the experimental code points at this point. So we welcome your review comments and suggestions. We requested early allocation of IANA code points on the mailing list. And we have also requested the working group adoption on the mailing list. And that's what I have so far.
I forgot to raise my hand. I'm sorry. Okay. Richard Foote, Nokia. I second your early adoption of a code point. It's going to make it much easier, co-author, to interoperate and not have to transition. So if we could really push for that, that would be very helpful.
Thank you, Foote.
Yes, we can help with that. Li Chang, in the queue.
Yes, Li Zhang from Huawei, and thanks for addressing my comments. And I think the draft now is useful and mature enough for working adoption. And one more suggestion is maybe we can create a GitHub repository to collaborate with other co-authors and contributors. It can use it to record their issues and can track their updates. It is very useful. Just a suggestion.
Yeah.
That is a very good suggestion. And one suggestion we could have if we adopt this is that we actually have a repository, or we have an organization for the working group that is now called IPPM. Soon will be renamed, and we are more than happy to host repositories if that would make sense. So, yeah.
So is this the first one getting adopted as draft BPM something?
That's a very good question. It depends on timing here. We're yeah, there will be a little bit of process here before that happens, but yeah. Thanks a lot.
Thank you.
Hello, everyone. Li Binliu from Zhongguancun Lab. I'm going to present the updates on the benchmarking methodology for router origin validation. This is a joint work with Nangeng from Huawei. So let's overview the document and have a look at the draft status. So this document is to define a repeatable and controlled benchmarking workflow for routers which implement the ROV and provide a standardized matrix that allows the comparison across the ROV products and the software versions. And it keeps the device and the test at the center and isolate the noises because we want the observed differences to reflect the ROV behavior itself. We uploaded the version 00 before the IETF 125 and presented it during the IETF 125 workgroup meeting. So during the meeting, we received some comments from Kristen, and based on the comments, we updated the version 01. After the meeting, we also introduced this draft in the CDOPS mailing list and required the experts to help review the document and seek feedback. So based on comments on my rear from Bird team, we updated 2 versions. Today I will present version 03. So let me repeat the motivation for this draft. Our V deployment is increasing, but there is no standardized device level benchmarking methodology. So we need common inputs, timers, and metrics to do the comparison between different ROV devices and the software versions. And the VRP scale, update churn, and the CPU and memory cost ROV have operational effect. So this should be tested. So this document fills a clear gap. There is no standardized and repeatable way to benchmarking the ROV behavior on routers. We have 4 key components to build the benchmarking environments, including RTR emulator, BJP generator, DOT, and a data plane tester. The RTR emulator is going to mirror a real cache or generate a synthetic VRPs, overlap cases, and controlled resets. The BJP generator is used to provide a baseline RIP and inject the selected prefix whose state will be affected by ROV. The data plane tester is used to generate controlled forwarding load to study how the traffic load will be affected by the control plane ROV behavior. So we also provide some requirements for the workload. For example, the RTR emulator should support controlled bursts, such as 100 to 10,000 VRPs per second. And the BJP generator should use a stable full table RIP and should generate advertise milling prefix. For the benchmarking tests, we provide 3 types, including latency-oriented, scalability, and robustness. The latency-oriented test consists of ROV update processing latency, ROV validation latency, and BJP convergence with and without ROV. The scalability includes VRP scalability and the capability to process VRP churn and the resource utilization. For the robustness, it's mainly about the RTR session behavior under different failover scenarios. So this test answers 3 questions. So how fast is ROV processing? And where is the scalability limit? And does the ROV implementation remain stable during the faults and churn? We have received, we here with summarize the comments we received on version 00 and our revisions based on the comments. Comment 1 suggests to consider the RTR data scale and structure. The parameters include the total count of ROA, the percentage of the whole address space covered by the ROAs compared to the address space announced by the routers. And we are also reminded that a chosen ROA may be covered by another ROA. So we extended the VRP dataset input conditions. So in this document, it asks the test to report not only the VRP set size and the churn, but also the total number of ROAs, VRP coverage relative to the announced routing space and the VRP overlap characteristics. The second comment is about the section 6.1. It may be different whether one single RTR update should modify one or more VRPs. Also, it is different for invalid by bad ASN or invalid by too long. So in the current draft, we clarified VRP update and the validation change characterization. In section 6.1, it clarifies whether an RTR update affects a single VRP or multiple VRPs. The document also asks the test to document the type of validation state change triggered, such as origin AS mismatch or prefix length violation. Comment 3, we are suggested to we have received some suggestion about the measurement data. The measured data may be different based on the scattering of the change VRP. So we agree with that. So in section 6.2, we added the affected prefix locality control. So we require that the test should report whether affected prefix are localized within the same region or distributed across different regions. We have received 2 comments about section 6.3 about the test procedures and the timer to calculate the BJP convergence time. We have refined the BJP convergence test in section 6.3 now. It separates VRP triggered BJP convergence from BJP triggered convergence with and without ROA. For the last comment, we are suggested to measure the full BJP recalculation after the RTR convergence. We agree with that. We extended the RTR recovery measurements in section 6.7. We now include BJP recalculation and convergence after RTR session recovery, cache failover, and full resynchronization. This is the summary of all of the main updates on version 0.3. So for the next step, we seek comments and feedback from BMWJ, IPPM, and CDOPS, and collaborations are welcome. And we are going to finish our prototype implementation and participate in the IETF 127 hackathon. Okay, thank you. I'm happy to take your questions.
Okay, thank you very much.
Thank you.
Next up is Nianjen Ye.
Good morning. I'm Nianjen Ye from Shanghai Jiao Tong University. Today, I will introduce a proposed switching efficiency framework for assessing how effectively AI data center networks turn its deployed switching resources into useful computational progress. In AI data centers supporting LLM training, both communication algorithms and network architectures can shape network efficiency. First, consider the original primitive. In a ring-based implementation, a GPU may receive intermediate or redundant data that is later discarded during reduction. This creates network and endpoint activity that does not directly become useful computational input. With in-network computing, reduction can be performed in the network, so the GPU receives only the final reduced result. This tool implementation can therefore exhibit very different efficiency characteristics. The same issue appears at the network architecture level. A 3D torus can efficiently support communication between neighboring nodes, but its distributed symmetric switching capacity may be a poor match for workloads with highly uneven traffic demands. By contrast, a rail-optimized architecture with centralized hierarchical switching capacity can better accommodate such demands but may incur additional multi-hop forwarding. These differences may not be visible from traffic volume or utilization alone. Our question is, can we define metric to quantify network efficiency for LLM training? File output and bandwidth utilization are useful starting point. However, they show only how active the network is. For LLM training, an efficiency metric must meet further requirements. First, the metric should distinguish computationally effective data from other traffic. Computationally effective data is the data retained and used as input to subsequent neural network computation. Not every byte carried by collective communication meets this condition. In ring or reduce, for example, unreduced intermediate data consumes network resources but is not retained after the reduction. A metric that treats all carried bytes equally cannot capture this difference. Second, the metric should capture workload topology fit. DP, PP, and TP in LLM training produce traffic that is often sparse and uneven. The metric should indicate how well the deployed network topology and capacity support the actual training traffic, rather than relying on static bandwidth properties. Third, the metric should be diagnostic. Beyond providing an overall efficiency score, it should help analyze sources of inefficiency and inform optimization efforts. These requirements motivate the proposed switching efficiency framework. Switching efficiency, eta, is the computationally effective data increment per unit time divided by total switching capacity. The left side defines the numerator. D is the full gradient or activation tensor per GPU, and delta Di is the data increment from communication primitive I that is retained for subsequent computation. Its value differs across communication primitives. Intermediate or unreduced data may consume network resources, but does not contribute to the numerator unless it is retained. The right side defines the denominator. Sum of RP as the theoretical egress rate of the included switching resources, from SPI and leaf switches to in-server switching. Eta therefore measures how effectively the deployed switching resources turn into effective data file output. Eta is then decomposed into three factors, which show where the efficiency loss occurs. To calculate these factors, we measure four quantities: C total times T, the total theoretical egress bytes over the observation window. We forward egress bytes emitted by the measured forwarding port in the measurement domain. We receive bytes successfully received at the measured endpoint, and we effectively retain data used as input to subsequent computation. The ratio between these four quantities yields the three factors. Post-utilization asks how much aggregate capacity was used. Routing efficiency asks how much forwarding work was required for data received at endpoint. Data efficiency asks how much received data was retained as effective data. A low point utilization points to idle or poorly distributed switching capacity. A low routing efficiency can reflect the tours with transmissions, loops, or topology traffic mismatch. A low data efficiency point to redundant or unreduced data. These factors separate capacity use, routing, and data efficiency causes of a low result. These NS-free or reduced results show how the matrix set exposes the source of an efficiency gap. We evaluate 5 or reduced algorithms across 16 to 128 GPUs on 8 GPU NV switch servers connected by a single inter-server switch. In this evaluation, ETAs follows exactly the same trend as algorithm bandwidth, a commonly used communication performance metric. ETA therefore preserves the familiar performance view while quantifying each algorithm's remaining gap to the network's ideal or reduced performance. The decomposition as the efficiency gap expression. Theta and gamma show whether a low eta is associated with unused switching capacity or with received data that does not become effective. This reveals why some algorithms achieve higher or lower algorithm bandwidth than others. Forest core experiment makes this concrete. Its theta is lower than that of most evaluated algorithms and declines as GPU scale grows, revealing underused switching capacity. Its gamma is also substantially lower than MVLS, indicating data efficiency limitations. Here we evaluate dense and MLE training at 4096 GPUs under multiple parallelism configurations. Each curve shows the mean value across those configurations as one network parameter changes. For dense training on 3D torus, adjusting the bandwidth allocation ratio across different torus dimensions raises aggregate theta from 0.32 to 0.57, indicating better use of provisioned switching capacity. For MOE on rail optimized, increasing server size raises both theta and delta. This indicates potential gains from reducing inter-server and multi-level forwarding. In-network computing affects different factors. For dense model training, it reduces endpoint data that is not retained as computationally effective data, raising aggregate gamma from 0.64 to 0.99. Taken together, these curves show how the decomposed metric attributes the effect of each design change to a specific efficiency factor. This slide shows the same experimental workload inputs as the previous slide, and each point representing one parallelism configuration. Data efficiency shows that redundant data reception is an important communication efficiency bottleneck for both the network architectures and workloads. Routing efficiency highlights the routing cost of MOE auto-all traffic. It remains low in both evaluated architectures, indicating high forwarding work per byte delivered to endpoints. Port utilization adds a third view. Rail optimize has higher factor in this evaluation, yet MOE remains challenging for both architectures. To summarize, switching efficiency provides a unified way to quantify overall network efficiency, diagnose and root causes of inefficiency, and guide the design of more efficient AI data center networks. We would like to invite discussion on two questions. One, how to decide representative workload to make switching efficiency results more meaningful. And two, how can the required measurements be collected conveniently and reproducibly? Thank you. That's all. Any questions or comments?
Yes, this is Carsten from ENTC. Thank you for reading the statement to us. It looks to me more like an academic paper than an IETF draft. So that's the one thing. So I'm not sure unless the style of this work is dramatically changed. I think it's not the right place here. And also it's hard for me personally to figure out how much of it is actually human work, because even you're just reading it, although your English is quite perfect from the pronunciation. So I think it would be a good rule for the future to require like a personal presentation so that we can understand how much do you actually gather this topic. And I'm asking this because section 5 in your draft is, depending on which AI detector you ask, between 30 to 100% AI generated. So I'm not sure how much human work is involved in this draft at all. It looks impressive, but for me, the bad taste remains, like maybe just an AI has spilled out the gamma, delta, and variables and has come up with these ideas. Can you comment on this?
For the first question, it is we want to proceed this academic work to an IETF draft, and we are connecting the industry to, like Huawei, to discussion how to make this be a more practical metric. And the second is I involved the jobs, and now I have to read this in by paper. Okay. Thank you for your comment. I'm Wei Changsun. I'm co-author of the draft. Nian is my student. So the basic idea of this draft is provide a very high-level metric for us to understand how the switching resources in an AIDC is utilized. A very good analogy I borrow from my interactions with an expert during this IETF meeting is PoE. So people, PoE is a very simple yet very communicative metric that people widely use when they design and deploy, evaluate data centers. So with this switching efficiency, we aim to provide a similar metric that probably can be used by, for example, ASIC designers. They are designing ASICs with different radix, right? Small size, bigger size, large port counts, and so on. So when these resources are deployed in AI data centers with different architectures, you may wonder how these different architectures, they differ in terms of the utilization of the resource. So we would like to make data centers operate, data centers be leaner and operate in a greener manner, right? In the sense that all the switching resources can be utilized. So this is the basic, the most fundamental idea that we propose. So I would like to say this is the first appearance. We try to bring this idea to the community. Of course, we have to turn this idea, this concept, into something that is concrete enough. For example, to make it a software, to implement in testing devices. I had a very good conversation with Professor Cui, who has a student who is now a leading measurement device manufacturer. So he's very interested in, for example, bringing our idea into something that can be implemented in a testing device. We have very high capacity device available to test the various elements in data centers. So probably this can be one of the features that can be implemented.
All right. Thank you for this discussion and for taking this work here. It's very much appreciated, and please keep engaging in the mailing list, especially if you want to transition this from something academic to something more, IETF engineering-like.
Yeah, sure. Thank you.
Encourage you to engage over the mailing list. Thank you very much. Right, and now we're moving into, and we're actually good. We're a little bit ahead on the agenda, but now we're moving into this section of more lightning style talks. So for everyone who presents now, please be brief, 2 minutes, do an overview of variety, and yeah, thank you.
Hello everyone, I'm Xiaomi from Chile Telecom. This document title is a framework for monitoring packet loss caused by network congestions. So sorry, I can't control the slide.
Yeah, we'll reshare it. Just a minute.
I can't control the slide. Next.
You should have control of the slides now. So, yeah.
Okay. Because of limited time, I only introduced summaries. This document describes a comprehensive packet loss monitoring architecture framework. The proposed scheme is capable to not only determine the time and the location of packet loss occurrences, but the accurate statistic of discarded packets, past what track flows are contained in discarded packets, and identify what track flows lead to MAC-best, but also obtain accurate packet loss ratio results. More importantly, the proposed scheme can achieve little or even no interference to network and is applicable to any data player without modified forwarding chip and packet head. The proposal framework mainly comprises network devices and the collection analysis system. The device is required to add 4 new functional modules: real-time packet loss detection modules, packet loss information reporting modules, cache modules for discarded packets, and packet loss file upload modules. Collection and analysis system mainly consists of 5 functions: packet loss data collections, message traffic flow collection, packet loss statistics, and packet loss ratio measurement modules. Welcome any comments and suggestions. Thank you.
Thank you very much. Thank you for being on time. Next up, Livin. Yeah.
Okay, one-page slide. So this draft is called Considerations for Interpreting Packet Loss Observed by Active Performance Measurement. It's going to address the interpretation problem by measurement in active performance measurement. So when the active measurement approaches looks at packet loss, a missing response, or timeout, the outcome is valid, but the result itself cannot tell us what had happened. So for the same observation, but maybe correspond to different causes, such as congestion, discard, routing or forwarding, change, endpoint behavior, filtering, or ECMP or link aggregation or validation related discard. So this document aims to separate the measurement outcome from the inferred causes and suggest some operational context to help do the measurement analysis, such as the telemetry context, routing forwarding state, counters, or other validation state. This document does not to define a new metric or protocol. And the question for the IPPM work group is is this guidance useful, and what context should be emphasized for the operators? So if you are interested, welcome to discuss it and send your feedback in the mailing list. Thank you.
Thank you very much. Next up is Mailington.
Oh, not this. Last one, I think. Yeah. Okay, Mei Chen from China Mobile. Okay, this is the chapter from a scenario that security evaluation benchmark for AI agents. We have implement a platform for the agents, and we have showed in the Hexagon project. So the goal for us is to establish a standardized benchmark to assess agent security across for critical dimensions. So the framework enables quantitative scoring, cross-model comparison, and the clear risk level here. We can see that the four dimension is foundation model, interaction security, and operational security, basic security. This four dimensions, and in detail metrics we have 55, I think. And from the scoring process and weighting, we use metric score and also dimension score and the final score with different weighting here. And also we do the two example here is that open core. Okay, we can see the version and Hermes. So for open core, the final score is a bit low here. So we think the high risk level is really critical. From our testing results that we observation that several feature in foundation model alignment and basic security protections and indicating high vulnerability to adversaries attacks. But the hammers, the final score is a little higher than OpenClaw, but it's almost below 16 scores. So it's also the high risk level. So we think the relative between operational security, but significant weakness in interaction security, like prompt injection defenses. We have individual draft in benchmark working group, and we also have create GitHub repo here for the security evaluation benchmark. If you select the Mail, you can find the project. And also I will zip the Hexagon project and also the GitHub address to the benchmark working group. Thanks.
Thank you very much.
Really short.
And next up is Luis.
I will just take it 1 minute. Yeah. So thanks so much. This is Luis from Telefonica. I will introduce briefly this initial idea about a benchmarking methodology for AI agents in network operations. So basically now that we are exploring this way of introducing agents for doing network operations, so troubleshooting, configuration, checking of the configuration, optimization, at the end management things. So to have a kind of methodology so that we can benchmark the behavior of the agents and basically understand if there are drifts, if there are some bias, if there is some performance issue in a multi-vendor implementation of these agents for specific tasks. So the initial idea is basically to introduce the point. We are defining in the draft trying to define what could be the system under test. So that would be the AA agent with a specific mission together with other tools that could be required for this agent to perform. And also the idea would be, okay, consider the model, the version, the configurations, the prompts that should be used for the specific testing for that specific mission or action that we are validating. Also, we are considering to define the benchmarking framework. So what would be the definition of the task that would be accomplished by these agents in the methodology, so that we could define some reproducible way of testing independently of the implementation of the agent. And here we could, things that we are proposing is to explore either the functionality of the agent as a standalone with a specific task, or even running multi-step workflows, or how this agent is capable of defining the workflows to be run, so that we can essentially benchmark different solutions provided by, or different ways of reasoning of the agent according to the different implementations. We are also proposing a number of metrics, performance metrics, of course, so time of completion, time to first action, and so. Effectiveness metrics as well, so the rate of success at the time of accomplishing the task, the degree of pass-fail ratio in terms of this task, and so. Efficiency of it, an important thing to consider is the consumed tokens in the actions, in all the reasoning of the agent, and so. Also the invocation of tools, so essentially to understand what is the behavior. The robustness, so how the agent performs against any distortion in the inputs that it could receive for performing actions, the stability, and so. And finally the coverage, so what are the tasks that is being handled by the agent, and yeah, basically how it addressed the problem. And finally, we are also trying to define what will be the format of the reporting of the task, and this would include the description of the agent, that is the system under test, the benchmarking frameworks, because we could have kind of different missions for the agent, so the definition of the task, the execution model, the logs, and the environment. Then the benchmarking metrics that we have referred, and finally the time to run and other relevant conditions, like basically what is the results, what are all the metrics covered, and so. The reporting that could be maybe following some JSON or YAML format or whatever, so depending on how we discuss what could be the proper way of doing so. If we are thinking on automation capabilities, probably YAML could be suitable for it. And that's all for my side. Thank you.
Thank you very much. We see we have one person in the queue, so if you have a quick question, please go ahead.
Hey, hello, I'm Yunzi from Tsinghua University, and I'm very interested in your talk, and I wonder how can you build a benchmarking or test cases that is vendor independent with for the AI agents? We find it very difficult to finish this task. Yeah. So do you have any opinion of it?
Yeah, that would be something that we need to think on. So what would be the kind of test to define, maybe to solve, maybe to have some kind of a reference network with some reference problems to be addressed by the agents. And this would be particular for the specific mission. If we are thinking on service assurance, or we are thinking on checking of the configuration, or I mean, there will be probably different roles for different agents.
Yeah.
And then we need to define some kind of reference scenario so that we can ensure that the different agents basically find the same setup for performing the action, and then we can have a valid comparison between the execution of these agents in these specific limits of defined by the reference case.
Okay.
But yeah, it will be probably not a simple mission to address.
Okay. Thank you.
Thank you.
Yeah, thank you very much, everyone. As you see, there are lots of interesting topics coming in here, and I would urge anyone who thinks that any one of these topics is interesting to engage in the mailing list. That is also to everybody who's proposing things here. It's always good to take it to the mailing lists and try to drive discussion there. That also helps us as chairs to kind of gauge the interest in this, because there is a lot of work. Okay, so thank you, everyone. Hope to see you in San Francisco in a few months, maybe under a new name.
Just one last remark. Also, Thomas mentioned in the notes, please check that your work is included in the current charter, because, and also your future plan. So please review the charter. Yeah.
We can schedule 3 sessions.
Exactly.
I mean, people get awareness, and then they can start the discussions, right? So
exactly.
Yeah, for the release statement, see that if you can just
exactly.
add it in.
It's got already feedback, so
Yeah, so I already, yes.
okay.